Today I am starting the another topic of relation and function, that is functions. So functions are like a machine that relates an input to an output. Or in simple language you can also say function relates an input to an output. So let's see it with an example. The classic way of writing the function is fx. So here I've taken a fx as 2x plus 1. So here you can see if I'll give 1 as the input, so after coming from this function you will get 6. So here you can 6, the input 1 and output 6 is related with the function. Now we will see in this chapter how the functions are related with the sets. In sets you can define functions as a relation between two sets where each element in one set is uniquely mapped to an element in the other. So you can see here each element is uniquely related with the another element in your set B. So this way you can represent a function. So let's make it more clear. Here you can see the element of A has two images in B. So this is not a type of function, means A has many B. This is not possible in functions. But here in the second case you can see B can have many A. So here you can see 1B is having 2A. So that is okay in functions. But when A has many B, that is not possible in functions. Here you can see I have taken 4 figures and you can see all these are example of functions. Here this A, here you can see A, C and D all are many one type of functions, but D is one function, means only one element is related with one element of elements in set B. Two sets which are non-empty sets A and B. A relation f from A to B is called to be function from A to B if every element of A has one and only one image in B, where the image of x is denoted with fx, and so you can write y equals to fx, and the element x is called the pre-image of y under the function f. Now let's see the types of functions. So there are 3 types of functions. First one is injective, second is surjective, and the third one is bijective. Now in the first, injective means 1 when one element of A is related with only one element of B. So this kind of function is known as 1. Now the second one is surjective, that is also known as onto. So in onto what happens? All the elements of B should be related with A. So that means nothing should left out in B. So that type of function is known as onto. Now you can see in this one, this is 1, but here one element is left out, so it is not onto. So only this one is onto. So in onto, many one is okay, but only condition is that in B there should be no element left, not having the pre-image in A. Now the third one is bijective. If a function is both injective and surjective, that means it is bijective. So it will be 1 also and it will be onto also. Means you can also think that each element is related with some element in B and nothing will left out in B. So now I think it is clear. In 1 to 1, 1 to many is not okay, many to 1 is not okay, only 1 to 1 means 1 will be related with 1 only. So it is injective. For onto and surjective, surjective means every element in B at least has one matching in A. So in B there will be no left out. Now the bijective, you know, when the function is injective and surjective both, then it is known as bijective. So let's see how can we check 1 and onto. So for checking the 1 and onto, I have just taken an example that a function f n to n, function from n to n, is defined as fx equals to 2x plus 3. Now we have to check whether it is 1 or onto. So now here, what is the meaning of this n to n? N to n means the domain means all the x will come from the natural number. N is the set of natural numbers, and the range means the image will also come from the natural number. Now let's see the steps what to do. The first step is, first let fa equals to fb. So first we will assume that there are two images fa and fb that are equal. So now we will put this a in this function fx, that is 2x plus 3. So this is the second step. So you will get this. Now the third step, just have to solve it. So if you are getting a equals to b, so here you can see fa and fb are equal, means the two images are equal when that particular values a and b are equal. So that means this function will be 1 1. So here fx is 1 1 as fa equals to fb when a equals to b, means two images are equal when these particular values are equal. So there will be no two different values for which you will have two same images. This is the way to check whether the function is 1 1 or not. The next one is how to check for onto. See, for checking onto, so first you have to let fx equals to y, then you have to find out x in terms of y. So here you will get x equals to y minus 3 by 2. Now you will check for every value of y, does x exist or not for the given domain. So if you will take y as 1, so you will get minus 1, minus 2 by 2, so that will be minus 1. So minus 1 is not a natural number. So for all natural values of y, x is not natural, now not onto. So this way you can check whether the function is 1 1 or onto.